Hello everyone, welcome to this YouTube video. I am Kaustubh Bhavsar and currently I am in my last semester of computer engineering at MIT Academy of Engineering. I welcome you all to this video in which we will be discussing about introduction to DevOps Lifecycle, and we will be completely going through the basics of the DevOps to the actual need and real-time applications of DevOps, where it is there in industry and what exactly its need is. So without wasting time, we will just move ahead. The agenda for this video is what we actually need to know about DevOps is the pre-DevOps era. Like, what was the condition of IT or the technological sector before the DevOps? Then, what was exactly need of DevOps? Then, what is DevOps? And then we will be discussing about DevOps life cycle, some important C's in DevOps, and lastly, the overall summary. This will be the like summary or a theoretical kind of discussion about DevOps, in which we will be discussing about all the concepts of DevOps from very basics to a quite a good level. And after that, after completion of this video, I will be bringing you the next video on the like dedicated video for the DevOps tools as well. And continually, we will be continuing this playlist till in which we will be covering all the DevOps concepts in very details. And along with that, what we will do is we will take any project and we can work on that. And I will demonstrate you how you can use all DevOps tools for any particular project. So let's get started. So, what is pre-DevOps era and its issues? The exact thing before DevOps was, suppose we are working in a company. So, in company there are a lot of teams. One team is regarding the development, one is testing team, one is operation team. So, each team has different functionalities. What exactly DevOps is needed is what we are going to discuss. Suppose if any company has to deliver a software in particular given amount of time, the issues are when a development team is developing that server, they encounter a lot of issues. But after covering all the issues, solving all the issues, they create a code, and after that code, they pass that code to testing team. After that, the development team starts working on the different kind of bug, and they continue their work. Meanwhile, what the testing team does is they test that particular code given by the development team, and it takes some time. As the process was for manual testing, they need to go through the lines of code, how the codes are working, are the existing functionality not breaking, are the new functionalities working fine. They need to check everything manually because there was no kind of automation. And after that, they are going to find any bug. So if you can consider, the development team has passed the development code to testing team, and after 2 or 3 weeks they are getting the bug from the testing team. Until that time, the development team is currently working on another bug. So again, they need to resolve that bug, because and now they are like working on the different kind of bugs. So it is a time of 2 or 3 weeks. They are also not properly efficient to crack that bug again, because they are already started their work on different things. So this is major issue. And after that only, if they are fixing the issue, bug is fixed, then again it goes to testing, the testing is passed, then it goes to operational team. The operational team handles the development. So it may happen that at the time of deployment, the server maybe get crashed because of different kind of environment at the deployment server. So suppose if a development team member is writing code and testing it on Windows operating system, and suppose the deployment server is working on Linux, so this can create a issue, and this also sets a rollback. So the complete issue is like, a company is working in a team of different like a lot of teams, and each like part of code or part of functionality is passed from one team to another, and if any issue is found, it is getting again rolled back. So the issue is the software is not developed properly, efficiently, and the delivery gets too much time. So it creates the issues for client also, and the trust of client to the company. So this was the biggest issue before DevOps. So as I have written here also, slow delivery rate, because there are a lot of issues. Separate development and operational team, their working was different. Then manual testing and deployment error. So as I discussed, they were going through lines of code manually. They were testing each and every functionality manually, and it generally takes time to human for process all these things. And So it was also difficult to collaborate because the teams were working in different part. So development team was not in that much contact with testing team, so testing team was reverting after 2 or 3 weeks, and it was taking months to deliver a particular software, and it was a biggest problem at that time. And also high failure rates in production because the issue of different environment variables was there. And the only thing which the developers observed is like there is not a proper collaboration or not a proper method of software development life cycle which they are using. Before that they were using a waterfall model or any kind of other model to develop a software. It was just a simple model, just develop model, test it, deploy it. If there is an again issue, then it was creating a lot of issues, and it was not they were not able to roll back for their own functionality. So this was all the pre DevOps era and a lot of issues. So because of that, we need something or some practice which will definitely help us to overcome all this issue, to give a faster delivery, and to achieve something in the field of development. So for that, DevOps come into the picture. And what DevOps, like I discussed the issues before DevOps. Now why DevOps? So I just told you what is the need of DevOps, because we need something for the faster and automated releases. As I told earlier, the deployment or testing process was continuously manual, but there was no automation. So DevOps brought the automation process in that. After that, what is continuous integration and deployment? It comes in DevOps, and it is also a part of DevOps, which is very helpful. And lastly, improved collaboration. So what were the major issues? There was no collaboration, no proper communication between different teams, and it was creating a rollback for software again and again, and implementing or resulting in big issues or big delivery time. So that's why we need DevOps. Now, what exactly DevOps is and how it is going to solve the issues? So like from all the past discussion, you might have understood DevOps is not something like a tool. It is a technique. DevOps is a concept, a methodology to work, or a practice which can be implemented in real software development cycle. So it is generally a collaborative approach that combines development and operations for faster, automated, and efficient software delivery. So if you guys can see the words faster, automated, and efficient software delivery, this was all which we were in need before the like DevOps era. So this is in short, it is kind of technique in which the two teams, the development team and the operation team, which were working on like separately, now they are working combinedly, and that is why the technique is named as DevOps, which means development, and ops means operations. So both the teams work together, collaborate together to solve the major issues. And yes, the biggest advantage of DevOps is before DevOps we need months to release a software. After DevOps we need days or some weeks just to release the software. This is the biggest thing in DevOps, because it brings the faster release, it brings the automated processes and efficient software delivery. So how exactly DevOps is going to solve the issues? It is like it automates the development, testing, and deployment. So the testers who were going through different lots of lines of codes and the functionalities, how the function is working or not, they just need to write some small manual, the automated scripts, and the scripts perform the testing. In deployments also, DevOps come with some tools which automate the deployment process also. So there is no need to manually check the environment, the manually check the deployment process. And after that, it improves the system reliability, because in DevOps there are some parts where the performance and the logs of the systems are continuously monitored, and after that it is providing us the like complete data, how it is going to affect our system, what other things we can improve in our system. And lastly, it ensures our continuous feedback. So DevOps comes with one method of continuous feedback. It is something like if the software is into production, clients are already using it, then we are collecting the feedback from client only, so that how we can improve our customer engagement with our software. So this is why DevOps comes into role, and this is how it solves the issue. So this is the complete DevOps life cycle. It forms an infinity loop. It starts with the planning. After that, coding and developing our system or our software. After that, we are building that. Then comes the test part. After successful testing, we release our software. Then it goes for deployment. After deployment, there are a lot of operations performed on it. It is getting monitored. And lastly, again, if there are any other uh, softwares or other changes, other things which we need to add up, then we again come to planning phase, and this infinity loops goes on and continuously goes on. This is how DevOps is there. So now I will be explaining you these steps in infinity loop, how these are contributing in DevOps life cycle. This is a DevOps life cycle and it is an infinite process. Starting with the very first, which is our planning. In this phase, we completely define the project scope, what are our goals, and what is our exactly requirement, how our software will look like at the end of our development. And for that, we use the agile methodology for iterative planning, because the older versions of software development, like cycles, like waterfall model or other kind of model, they were not that much customer friendly. So we use agile, which is more compensated with the DevOps like technology or the DevOps practice. And we use tools like Jira and Confluence for this. So as I already discussed, I will be coming with a detailed video regarding the tools, how we are going to use that. So here I'll just give you the small introduction. After that, we come into the development section where we are actually writing our code by analyzing our requirements and our goal, and we have manage our source code. Here comes the part where too much like a different kind of developers, they store the code at one place, they use the same code and develop the next part and next feature of our code, and for that they need a smooth collaboration. And here comes the github and bitbucket part. Then we have build phase. In this phase, we convert our source code into executable format so that it will be helpful for us to get it deployed or released in an easy manner. This completely automates and compiles our packaging, and for this we use the Docker, Maven or Gradle X tool. Then there comes the test part. This is very important phase where we ensure the quality throughout the automated testing. Then we identify the bugs before the final deployment. And you guys might be knowing, the developers who already are working in a company, they might be knowing. But if you are a fresher in a company, the software has different kind of servers, starting from the mock server, QA server, development server, and lastly the production server. So all the code is tested till QA server, and the complete and the error free successful code is sent into deployment, the production, and after that clients are able to use that. So for testing, we generally use the Selenium, JUnit, or TestNG kind of tools. Then there comes the release section. Here we prepare the application for production. This is also not the actual production, but yes, we are going to prepare it for production. And for here, the part of continuous like integration and deployment comes into the role, and the tools are Jenkins, GitHub Actions, and other. And then the actual deployment part comes into the role, where we deliver our application to production server. We use this containerization and the scalability features of DevOps, and the tools are again Docker, Kubernetes, or Ansible. And last two, operate and monitor. So in operate, we ensure our system's availability and reliability. Here we check whether there are any performance issues or any logs which are creating the issues in our software, and we like navigate it to again development team. Here we manage the infrastructure and automation of our complete software, and for that we again use Kubernetes, Terraform, or Chef. Lastly, the last part is monitoring. After a successful deployment and operated like our software, we are going to monitor it. We are taking feedback from the user whether there are any issues in our software, and if there are not, then what can be improved, or if there are, then what, how can they be improved. So this is all in monitor, where we continuously track performance and log. We detect failures and security threats, and we use some tools like Nagios. So after that, the DevOps lifecycle consists of some C's. These are seven C's of DevOps, which are very, very, very important for any DevOps engineer. It comes with the continuous development, continuous integration, continuous testing, continuous deployment, continuous feedback, continuous monitoring, and lastly, continuous operation. Everything, each and every phase starts with C, which means continuous, and continuous in sense it is going continuously because it is automated. There is no manual work required here. That's why we can rely on machines, rely on tools for this, and it is continuous. The continuous development is a part of planning. We can say the further part of planning phase, where we ensure the structure and collaborative development, and we plan, and this is a kind of planning and coding phase. So plan and develop, we can consider it as together, and we use agile methodology for that, and we use Git for version control software system tool. And then continuous integration, so this is the part where if I have written any code, it is deployed, and I want to add new feature in that, so I will again integrate it with the actual repository of my code on maybe GitHub. So this is kind of continuous integration, which is merging code frequently into our repository. This reduces our integration errors, because if I am like deploying my code, and after that I'm working on 10 different functionalities, and I'm directly pushing all 10s, so it might create integration issue. So apart from that, what I can do is I will merge one by one, continuously integrating my new written code into the earlier existing code. And lastly, we have automated build and unit test here. Continuous testing is very much important. In this, we detect bugs continuously by performing the continuous testing on our software. This comes with automated testing of new code, includes unit integration and performance testing. Then we have continuous development. So here we ensure the consistency and like error free releases, so that there are like no or maybe very little errors in our software, so that we can just avoid them. And then we automate our deployment to different environments. The issue was before DevOps was, if any software developer was testing his all the changes on different kind of setup, and then at the time of deployment the setup or the environment is different, it is going to give 100% error. And this is not a problem of developer also, not a deployment person also. So to avoid this, what we can do is, DevOps is something which gives us the continuous deployment, and the tools come into the role which like help us to do that. And for that we use containerization, which is a part of Kubernetes. And the other thing, then we have continuous monitoring. Here we check our software again and again, so that it might not contain any kind of issue. We detect any failure, and then optimize the health of our system. We also track the application performance and security performance logs, and we use log alert and real-time analytics for that. Then lastly, there are two, which is continuous feedback and continuous operation. So in continuous feedback, we are generally taking the like we are taking the feedback from the user, like are they going to face any kind of difficulties while using our software, and if yes, how our team can improve that and change that. Then for that we use the gather feedback for improvements from the clients, and we use analytics and issues to tracking tools. Then lastly, continuous operation. It keeps our application running 24 by 7. So at any time we are not going to face downtime. Earlier we used to face downtime because of lot of issues, but now it keeps our application running 24 by 7, which ensures our zero time downtime and automated maintenance. And we use auto scaling and failover and backups for this. So we are done with all the discussion regarding the basics to advance of DevOps. We have not covered any kind of tool or any kind of practical work in this video, because it was a theoretical introduction to DevOps lifecycle. So in conclusion, DevOps is not a tool. It is a mindset, and it is a faster, reliable, and automated software development practice which we should incorporate in our software for efficient delivery and efficient process management. This reduces our manual works, it speeds up our delivery, it ensures continuous improvements and automation. So that was mostly it from my side. Thank you so much if you are till here at the end of this video. For any kind of discussion, you can connect me on LinkedIn, or for any kind of feedback, I'm always open. You can share it in comment section. So just last thing to share is, DevOps is not our goal. It is a never ending process of continual improvement. It is something which is really helpful for developers. So thank you so much for watching this video.